So we'll start now the second session of TEAS. So welcome everybody and thank you for staying till Friday morning and surviving Thursday night. And well, we have some people remotely that I hope that eh, they can hear us properly and they can know some people traveled yesterday and they are attending remote today. So I hope that we can have really good discussions today. So just remind you that you need to follow the IETF rules and processes, as we mentioned yesterday and we mentioned in every session. So you have here all the information, and especially today that we are gonna devote the day for some discussions. So we remind you to extend the respect and courtesy to your colleagues all the times and keep the discussions impersonal, keep them at the technical level, and remember that we meet together with diverse technical backgrounds. So contribute. Okay? So don't be careful with the discussions. And then just remember to sign in. Okay, so everybody that is in the room, just remember everybody to log into the tool, and at the moment that you need to speak, always remember to click the button before. Even if the discussion is very heated, click the button and then go to the queue. Just as a reminder of all the tools that we have, and remember helping the note taking, especially to capture properly the discussions, which are the main points where we need to take actions, have all the materials, the information data tracker, Sulit. I will go directly for the agenda for today. So the agenda for today is mainly focused on slicing. Okay, so we will start with some nice discussions with the scalability consideration for slicing, and then we'll have a set of different documents, all of them aimed at different flavors or different actions around slicing. So it's I think the last two ones, the DC-aware-T topology, and finally we have this presentation of the refinements of the network topologies that was presented also in OPS. Okay, so and I think it is really also interesting to. We thought last year that it was interesting to see it here because it deals with fundamental changes in the traffic in how to build topology. So it's useful for this to discuss whether they are here or not. So I think we can jump now to the first presentation.
Okay, morning everyone. This is Jino from Huawei. I'm going to give an update about the current status of this scalability consideration for NRP draft, and also some recent discussion about the scalability of the NRP and network slicing. Okay, next slide, please. Okay, just a quick recap about the network slicing and the NRP concepts. We know that in the IETF network slice framework draft, it mentioned that the network slice services can be realized by mapping network slice connectivity constructs to the underlying NRPs, and also give the terminology and the definition of the NRP, which is a set of dedicated or shared network resources, and it can be associated with a filtered topology. An NRP can be used to support one group of the network slice services. This can help to improve the network slice scalability. Well, the scalability of the NRP itself is also important if we want to consider wider deployment of the network slice services in the IETF networks. So this document provides scalability considerations about the NRP in both the control plane and the data plane, and also propose some suggestions about the optimization of the optimization mechanism both in the control plane and the data plane. Okay, next please. Okay, here regarding the control plane, the NRP scalability can have some impact to the distributed control plane in the following aspects. We can consider the impacts to the control protocol, the number of the control protocol instances, or the number of the protocol sessions, and the number of the messages, the number of the attributes or the information in each message, and also the number of the computations related to the to be executed by the network node if we consider the increased number of the NRP. This is for the distributed control plane. Well, we also consider some concerns about the scalability of the centralized control plane in terms of the processing burdens of the global computation to be executed by the controller when there's multiple NRPs to be optimized or to be established concurrently. And also when there's a link change or node change in the network, it may have impact to multiple NRPs, and the information update about the NRP in real time can also bring burden to the communication channels. Okay, next page. Regarding the data plane, we know that we have seen the need of the carry some identification of the NRP in the packet. It is currently called the NRP data plane selector. We have different options to encapsulate this information in the packet, and currently there are mainly two options we are considering in this document. The first one is we can reuse some existing fields in the data packet to identify the NRPs, such as we can use different SRCs for different NRP or IP addresses or MPLS forwarding labels. The pros of this mechanism is there's no need to introduce additional encapsulations to the data packet. Well, there's also a set of cons, which is as listed here. You may have the scalability issue to the existing functionalities. I think it may require some change both in the semantics of the existing fields and the processing behaviors. It may also cause some control protocol extensions needed to support this functionality. Then the second option is we can consider to introduce a dedicated data plane ID. It's called NRP ID, or some other terms that may be used in different documents. For example, we can use some dedicated ID carried in the IPv6 extension headers, or we can introduce a special purpose MPLS label, or we may also consider the under discussion M&A mechanism for the encapsulation of the NRP ID in the MPLS packets. The pros is apparently that it can avoid the impacts mentioned in the option one. We don't need to impact the existing fields in the semantics, in the functionality, or the control plane extensions. So it can have better scalability compared with the option one. And the cons is we need to face the cost of the new data plane encapsulation, and we also it may also require some control plane extensions. Maybe compared to the option one, it may be less extension needed in this option, but still we need to consider whether some option or some control plane extensions will be needed in this option also. Okay, next page. So in the current draft, we propose some scalability optimization mechanisms in both control plane and the data plane. For the control plane scalability optimization, mainly the major principle is we can consider to use shared control plane components for multiple NRPs, such as we can consider the shared protocol instance or shared protocol sessions for multiple NRPs. And we can also, when the topology of multiple NRPs are the same, we can also consider to share the topology-specific computation and information distribution. So this can save the control plane resource and can reduce the message exchange for the NRPs. And the third point is we can use a hybrid control mechanism with both the control plane, distributed control plane, and also the centralized controller mechanism, so that we can solve the bottleneck on each of them. Regarding the data plane scalability optimization, I think as we just discussed in the previous slides, we propose to introduce a dedicated resource ID in the data packet comparing to the current package header, we have the topology specific IDs, like the IP address or the SRCs and pairs labels. They can consider as existing IDs or fields used for the topology identification or the path identification. We can introduce a dedicated resource ID so that it can be used to identify the NRP resources during the packet forwarding, so that we decouple the resource ID from the topology ID. In this case, this can, as we discussed in the previous slides, can reduce the overhead in the control plane, also the forwarding plane. Okay. Next slide.
Do you want to take questions?
Okay.
So great.
Or maybe later. Okay, let's continue. Okay, here are some updates about the draft after the working group adoption. The version 01 made comprehensive editorial changes based on the review comments received both during and after the adoption poll. So we would like to thank people who review and made comments, suggestions to this document. And the 02 version is just a minor updates with just for the refresh so that we can continue the discussion in the working group. Okay, next page. Okay, now we come to this recent offline discussion about the design principles of the scalable NRP. We have discussed for a while, and we list several items here. This is still not we cannot call it a consensus, just most people think this is a reasonable summary for the recent discussion, and I will not read it through since there's a lot of text. In general, we can see that this discussion, the summary of the recent discussion, kind of align with the content in the NRP scalability draft, but it can be more specific in some of these items, like we may consider the separate identifiers for the path, NRP, and topology, but this is a separate semantics, but whether we carry it in existing fields or in a new field, it still depends on the different solutions. So this is a part of this summary of the discussion. We will have another one more page on this summary in the next page. Okay. So please, if you want to go through the text, I think Adrian has sent the mail to the working group mailing list. You can check there also, and we can discuss either during this meeting or the offline on the mailing list. Okay, maybe we can move on.
You have 4 in the queue if you want to take it now. Your choice.
Maybe we can finish. I have maybe 1 or 2 pages left. Okay, this page is about some discussion, opinions on the solutions with different scales. In summary, we think some of the people in the group of the discussion consider that we need to consider the trade-off between the optimal solution and the scalable solution, which means that we need a scalable solution which can be deployed in all the scenarios. Well, for some specific scenarios, we can also propose some solution optimized for that case, but may not be that scalable. So we may allow both to be discussed and documented. Well, as long as this document can provide a scalability consideration so that it can clarify what kind of network scenarios it is designed for and what is the scalability limits or the properties of this solution, that would be fine in our understanding. Okay, maybe next is the last page. Okay, the next steps for this draft and also this discussion is we would like to have further discussion in the working group on the NRP scalability, and so that we can reach some consensus on the design principles of a scalable NRP solution. And we can, after this, some of this consensus maybe can incorporate it into this NRP scalability document so that we can keep this document as a a complete set of the scalability considerations. And we also suggest that all the solution documents must include a section on the scalability considerations so that we can have a clear understanding about the applicability of different solutions. Okay, so that's all comments.
Okay, Greg Mirsky Erickson. I have several questions. So as I understand, if I understand correctly, you believe that requiring dedicated NRP identifier, introduction of dedicated NRP identifier is the right approach.
It's a more scalable approach based on the analysis, right? Otherwise, we will
But
need to.
it clearly will have impact on the data plane because it adds complexity. And for example, if we see that um, if we assume that at least for MPLS data plane, it will use M&A approach. So that will require that existing hardware must support M&A and thus would not be able to support network slicing.
Yeah, exactly. And that's the pros and cons of this scalable solution. That's why we also suggest to document the solutions with existing data plane, which means they may not be that scalable, but they can meet the requirement of the customer in some of their network scenarios.
But it seems that it's not a question of scalability, it's question of applicability. So basically, the path that you are suggesting will make some equipment not capable of supporting network slices.
Yeah, that is we just
it's not scaling, it's deployment. So you're eliminating.
Yeah, each solution also have their deployment. May have their deployment considerations also, that's my understanding. Because if you have introduced data plane extensions, that is also we always need to consider how to deploy it or to operate it with legacy devices in the same network, right?
But so what your recommendation for deploying in existing networks that are not capable of supporting M&A?
Yeah, I think we in that case we will give the option like using the existing fields to represent the NRP identification information, like using the Cs or the labels.
But that leads to doing the same thing many different ways, which is interoperability problem, right? So basically, would it be easier and simpler to use existing methods and depending on the data plane and solution for IETF network slice to use identifiers that are suitable for existing technologies, not to introduce nothing new. So just use what you have and introduce new only when you really must.
Yeah, I think we are kind of on the same page. We consider the existing data plane mechanisms are also useful and important for some of the deployment. Well, some people are concerned about the NRP scalability, and apparently the existing data plane have some issues in that case. So we can consider both optional, and which one to choose for a specific deployment. That is something maybe we can depend on the operator's choice, or we can also have some document about the analysis or some recommendations.
So, Greg, your point is taken. I think
okay, thank you.
We do have various ways of marking the packet to help select an appropriate NRP. Whether we need to recommend one particular approach or multiple approaches, that's something that the working group has to decide. Clearly, there are options available where you could use existing fields in the packet to act as an NRP selector. The one approach that G was talking about is, at least from the authors of this draft point of view, is a scalable approach, but that's up for debate. Tarek?
Okay, Sad, Cisco. I am a co-author, so it's not a question, but seeking feedback. There are important messages that are in this draft about scalability concerns and different approaches or options for different deployments. And there are different drafts in different working groups that are proposing or competing or different approaches than what the message is being given here. So how do we approach enforcing these messages that we're proposing in scalability draft?
Is this a question to me or to the working group?
I think it's to the working group as they're looking. I mean, everyone is looking to TEAS to give the direction, and probably the chairs have an approach or opinion
So-
to sound.
To lay down the list, right? We do have extensions proposed in PCE and IDR where you can associate either a T tunnel or a policy with an RP. So there are a set of extensions that fall under that category. We have some, like Greg was pointing out, there is proposal in MPLS that talks about carrying an NRP selector using M&A. There are similar approaches for V6 as well in other working groups. There are a bunch of extensions in LSR that talk about distributing NRP sits. There's another bunch of extensions in LSR that talk about carrying extensions that would help distributed NRP aware traffic engineering path placement. So the extension that talk about carrying per link per NRP attributes. So they're all out there, and the hope here is that by the end of this discussion on the list, we should be able to come up with at least a set of recommendations for the immediate future. Maybe there'll be a few that would be up for experimentation for later, but yeah, the immediate task would be to put together a set of recommendations that we could consider for the immediate future. Joel, go ahead.
Joel Halpern Erickson. Thank you for your work on this. And there are definitely some interesting questions about identification and data plane and control plane. And you're doing quite a good job of trying to bring it together and get us to a point we can make a decision. I wanted to float something some of us have been talking about that is not a fully fleshed idea, which is why there is no ID that captures it, but may be helpful on the control plane side. If you make some assumptions, and this is part of the problem, what assumptions are the right assumptions? But if you assume the existence of a reasonably competent management plane that can specify where NRPs are supported and how to interpret any identifiers of whichever kind we need, there may be a way to scale the control plane component here rather better than suggested by these slides, namely remove all control plane information. And 0 is the best scaling point we can get to. So I wanted to just float this in people's heads to think about whether, is there a way to get there? Is there a way we could use that? And think about what assumptions they think are relevant for that and whether those assumptions are appropriate or inappropriate. Those of us having conversations will be taking it to the list. I just wanted to float this because you did a very good job presenting things. Thank you.
Yeah, thank you. We can continue the discussion on the list.
Srihari? Srihari, can you unmute yourself? Okay, we'll go to Adrian and then come back to you, Srihari.
Or type it.
Or type your
Thanks.
question on the chat.
Adrian Farrell. I think some of us are talking past the problem here. Since slicing is a network service function, there will always be many ways of achieving it. Some of those will use existing technologies and some of them may propose new solutions. I think what G really nicely suggested was that all of the proposed solutions, whether they're informational frameworks about how to use existing technology or whether they're new protocol things, they should all contain a section which presents a quick overview of these are the scaling implications. This is what works well. This is what doesn't work well. Just as a nice way for other people to look at the solutions and choose which ones to deploy.
Okay, thank you.
Any other questions? Anything specific to the extensions? Joel said no control plane extensions at all. Anybody has any opinion on a limited set of extensions? I mean, there are various classes of extensions that are being proposed. The strongest resistance that you've seen is from folks in LSR saying that there shouldn't be any extensions discussed there at all, for good reasons. But trying to seek inputs on how to go about this, right? Would it help if we have, if we document an approach with where we can realize network slicing using NRPs with no control plane extensions at all? That means that everything goes to the management plane. Everything, you still need something to be programmed on the device, and we're going to rely on some programmable APIs to take care of that. Would it help if a solution along those lines is drafted and we discuss it? When we are individual contribution driven organization, so unless somebody puts out at the draft, yeah, we will be stuck in this limbo. Okay, we do have some time towards the end. If we do manage to keep to the schedule, we can get back to this. Next presenter, Louis.
Hello everyone, this is Luis from Telefonica. I will present the draft on the IETF network slice application in 5G for end-to-end network slice on behalf of my co-authors. So next, please. So just a bit of background introduction about the story of the draft. Among the different cases that were identified in the framework document for applicability of IETF network slices, there was the case of 5G. So at IETF117, the working group decided to document this, to create a document merging three different documents that were existing at that time, addressing this particular use case. So we have been refining the document, following the suggestions and comments from the working group. And yeah, basically what we will present today is where we are in this process. So we have been trying to improve the document structure. We also have added some examples. We will go through one of them today just for illustration purposes. And then we have done some polishing of the document regarding terminology, figure, numbering of the figure corrections, and so on and so forth. So editorial things. Next, please. So regarding the structure, we restructure a little bit the document, trying or pursuing the idea of having the document much more clear. So in one of the sections, we scope the document about the different possible 5G scenarios. So trying to somehow set the scenes for the discussion that comes later in the document. Also, we combine the management and control plane stuff in one particular section. Before that was separated. And when we added as well examples with trying to illustrate how how we could, let's say, make use of the NBI model for IETF network slices, departing from the kind of object classes the 3EPP is defining in the network resource management specifications in 3EPP. Also, we move toward the annex, some informative content, more background about 3GPP, and also the different implementation options that could be found in the field, so that we can keep somehow some registry of the options in the annex. So next, please. Going into the examples, I will elaborate one of them a little bit more. That will be based on this case. So we are trying to document different options. What we call CE-based slice demarcation point, but essentially we could consider the SDP as the loopback of the CE that is reflected in this case. So somehow extending the slice between the loopbacks of the CE, essentially. That would be the point. As you can see in the figure in the bottom part, so we are trying to relate on top of the MBI model defined in IETF, the parameters that are being defined in 3GPP in the spec 28.4.1. So for the same set of parameters, we will see different options. So that will be one option. So we take that information, and with that, we establish the slice between the loopbacks. Will be this case one. Next, please. We will have then the case two, that would be that the case of establishing the slice between the PE nodes, so essentially between some ports in the PE, and also referencing the attachment circuit for establishing this slice end-to-end. As you can see here, in this case, the endpoints or the SDPs that we, well, the endpoints in the 3GPP part would be the kind of object name EP transport in 3GPP. So essentially, what would be the port in the CE. Okay, and next, please. Another case that we are working on, this would be this PE-based case, where we also consider all the working attachment circuits that is being basically defined in draft Boro and so on. So let's go now through a specific use case, so you can see a little bit more the details of what we are doing in this exercise of using the MBI model with in a specific scenario. So thank you. So as you can see in both sides of the slides, the information that we would have will be the information that is provided by the object classes of 3GPP. 3GPP defines two basic object classes. One which is called EPRP. EPRP makes reference to the function itself. So it could be reference to a UPF, reference to a unit B, reference to a CU if we're talking about F1 interface. So in essence, the reference to what would be the function. And then we have the EP transport. The EP transport describes the details of what would be the point where the function in 3GPP expects to deliver the traffic. So as you can see, there is a relationship between those both objects, and 3GPP defines both objects in both ends of the communication. So with that information, the exercise is to take those parameters and trying to map to the MBI model being defined in IETF MBI draft. So, okay. This is essentially the exercise that we will try to map. As you can see, the realization of the slides will be equally applicable to different kind of associations between different entities. And we illustrate that, for instance, saying that with the same exercise, let's say we can map even a slice between GA node B and UPF, or if we are talking of F1 interface between DU and CUUP. So basically, we can do we can apply the same method for different let's say, objectives for this slice. And we will illustrate this with the CE mode that we referred at the beginning, the example number one. So next, please. So that would be the case, right? So from the data that you saw 2 slides ago, essentially we can do the mapping to the different objects. For instance, the SDP would be the loopback, as we mentioned before. The loopback was defined in the EPRP because it's the identifier of the function. Similarly, we have the identifiers of the interfaces that would apply to the attachment circuit, the VLAN. I mean, identifying the attachment circuit is a VLAN, and also the identifier of the VLAN. In this case, is identifier 100, and so on and so forth. Also the SAP, and well, this is basically the exercise that we are trying to describe in such a way that we can follow how to consume, let's say, the objects that will come from 3GPP. And on your right side, you can see the mapping, a preliminary exercise of the MBI model, in order to simplify how will be the consumption of this information. So next, please. So we commented on a number of comments. As said, we have been working on them. There are yet to be, some of them are yet to be addressed. So we were progressing on the modification of the structure of the document, also trying to clarify the scope and the relationship with other efforts in IETF TEAS for the network slicing with the other drafts, as you well know. Also alignment of terminology, polishing of the test, and we are yet working on gap analysis and trying to let's say, align the draft according to the different advances that are being done in 3GPP, but also in IETF, or like in draft Boro and so on and so forth. So comments are welcome. Comments are also encouraged, and review of the draft are also encouraged. just to be sure that the way in which we are doing the exercise of mapping or using the MBI model for slices is correct, and basically to get the assessment from the working group that the examples are properly done and essentially useful. And that's all from my side.
I just have one question. So, do you have regular collaborations with 3GPP, or it is just reading their documents just to know if there is some interaction?
Well, we have more regular collaborations with Oran. Oran is taking the same kind of specs that 3GPP for slicing, and what we are doing from Oran is to set liaisons to 3GPP. So there are liaisons from Oran to 3GPP trying to align the gaps that we are identifying here in IETF. So it's somehow indirect contribution to Oran via, to 3GPP via Oran.
Thank you.
Okay, thanks, Luis. We'll do the next one. Okay. We're done with the working group adopted documents. The next set of documents would be individual drafts.
Yeah. Hello again. So I will go through this other draft, which is about the instantiation of IETF network slices in service provider networks. So trying to exercise how to consume the different models that are being defined. Here for slicing and then for network models and service models. So next, please. So the context of this draft is essentially to cover the models that are on top of the network slice controller and how those models, the MBI model basically, and some others like the AC and so, relates with the models that would fit the network controllers for the instantiation of the slices, the realization finally of these slices using service models and network models. So next, please. So the draft has been presented in a number of IETFs already. We keep continuing cleaning up the text and restructuring the sections, so trying to make much more clear the document. So we, in this occasion, we have added text reference in service attachment point and access circuit models that are also being progressed in IETF. And we have added we have improved, let's say, via a new figure, the relationship or the overview of these data models and the network slicing. So trying to have a kind of map on how they relate so that the different drafts could be much more consumable. I mean, how they, to build the story, let's say, basically. And we have added MET as well as co-author. So next, please. This would be the figure that I was referring, the overview of the relationship between the different data models. So we would have from the customer side, the usage of customer service models, like the slice service models, so the MBI Young, the attachment circuit, and the bidder service models. With that, the relationship would be progressively relate that with the layer 2 VPN or layer 3 VPN network models, the SAP, and the AC in network. And then basically reaching up to the point that we essentially configure the device and set up we realize the slice end to end. All of this is the purpose is we are describing on all of this in the document. We are also identifying gaps in this kind of translation between models, so in such a way that we can identify further actions for bringing here in IETF to standardize and close the gaps. So next, please. So the next steps, we have yet identified pending improvements. We need to align, as always, because it's continuously progressing with the latest version of the MBI model. So we need to look for consistency in that respect. Also, we need to better describe the implications of not having a total alignment with between the parameters in the MBI model and the ones that could be in the service models and network models. So just, again, to ensure consistency and understanding if something is missing in the MBI model so that we can fill up for being sure that all the chain of the progress of the translation between models is properly done. And also evaluate maybe some other scenarios that could be the ones where from one service model we derive the need of applying an slice model. That could be, for instance, the usage or the request of realizing an OTN slice for a VPN service model, for instance. So this is not yet covered in the document, so our idea is as well to address this further comment. So we would like to have more feedback or comments from the working group for enhancing the document, that's clear. And also, even though we are knowledgeable that there are pending issues yet, we think that it's somehow stable the document, and also that it could be interest. I mean, we would like to ask for adoption because we see interest on also having this kind of document for understanding how to correlate all the models from the customer request up to the realization of the slides. And that's all from my side.
Any questions for Luis? So we have a working group adopted document called ACT and Young that talks about how all the Young models defined in IETF spread across working groups are applicable to the ACTN framework. The way I see it, this is talking about how all the Young models defined in IETF are applicable to network slicing framework, right? And the last time you presented it, we said there's a similar draft, which is the ACTN applicability document, which also does a similar job of explaining how existing models can be applicable to network slicing framework. So I'm still struggling to understand why we need this. I mean, it has lots of good content. The first issue I have is with the title itself. I mean, if you say applicability of Young models to network slicing framework, I think that is more appropriate. I mean, that's my personal view. Right now, it's if you look at the title, it sounds as if it's it's yet another instantiation draft out there, which may be contradicting to the previous guidance that we gave. So first question is, did you have that discussion? I think we had a brief discussion at the mic yesterday. If you can elaborate a bit more on.
Yeah, but basically we were discussing and commenting about that possibility, but we think that this somehow would we be missing things that are not totally mixable. Let's say the ACTN has the purpose of the specific ACTN architecture that could be not always the architecture that you can find in the operational networks. So we think that essentially would be somehow forcing to take to put together all the content would be somehow forcing the document. We understand probably that there will be another possible merging much more natural with another draft that is now, the draft Contreras that is talking about the internals of the network slice controller. I know that we have this discussion in the mailing list, and so that would be probably much more natural because somehow follow that chain. It's not, not looking into a particular architecture that could be a CTN, so it's much more generic, just simply linking the different models. At least this is our perception, and I think that is the same perception from the authors of ACTN draft. Dan is in the queue.
Go ahead, Dan, go ahead. Oh, he's off the queue.
Hi, thanks. Yeah, so just to kind of echo some of the comments I've just been writing in chat there, and speaking as an author of both this document, thanks Luis for summarizing the current situation, and also as an author of the ACTN applicability to network slicing. There are sort of subtle differences between the documents, so our ACTN applicability document is very specific to the ACTN architecture and the current available models, whereas this document that Luis has just presented actually sort of has a wider scope that includes, some ACTN content, but several other potential documents as well. So I think just sort of thinking aloud and putting some thoughts in the chat there, I think we can certainly reference the documents. Certainly in this instantiation document, we should reference the ACTN applicability. We can highlight the ACTN models as well. But in terms of kind of merging the document, the fact that there are sort of distinct differences, I think it will be extremely difficult to kind of successfully merge that.
Okay, fair enough. We will let's take the discussion to the list, see if there are other ways of merging some of this content into other documents. If we do go proceed with this, then I would at the very least like a change in the title, but yeah, we'll discuss that further.
Okay.
Thanks.
Thank you.
you hear me? Can you hear me?
You're very low.
Yeah, very low.
I will make it louder. How about now?
Still low. Bo, do you want Tarek to present instead?
Uh,
Okay, I think we
yeah,
can hear you now. Go ahead. Yeah.
yeah.
Go ahead, Bo. You
Tarek?
can present. We can hear.
Okay, you can hear me now. Okay, thank you.
Yeah, yeah.
Okay, so hello everyone. This is Bo. I'm here to present NLP Young model on behalf of all my co-authors. Next slide, please. So slides, this is about the background. So the motivation of NLP Young model is to be used to realize IETF network slice services. So this draft is a merge draft of NLP policy Young model and NLP Young model after last IETF meeting. So both parents drafts were presented in TEAS working group several times. Now this draft support a more comprehensive scenarios. So you can see the figure in the upper right shows where the models are used. There is a network model and also a device model. The model can support both configuration and monitoring. The bottom figure shows 3 examples of NLP instances. You can see that the blue one and the green one share same topology, and the green one in the middle has a dedicated topology. And each NLP has a subset of topology specific underlay network resources. So next slide, please. Then this is about a model design consideration. So the goal of this model is to support various NLP control and data plane technologies. Jay just presented many. And as I mentioned in the previous slide, the topology is a quite core component of NLP. The figure on the left shows that NLP model augments IETF network model. So during NLP instantiation, the NLP model can use the pre-built topology as much as possible, either by filtering or by directly selecting. The figure on the right shows high-level components of NLP model. The NLP network model and device model share some common components, such as topology, resource reservation, queues policy, and NLP selectors. And next slide, please. Then this slide gives more details of NLP device model. You can see that the NLP device model augments the NLP network model, and NLP device augments specific NLP policy with interface list to override device local attributes, such as the bandwidth, queues policy, and data plane selector. On the right, you can see that the specific place that network model and device model located. So next slide, please. This is the end of my presentation. I think the author thinks the model now are quite mature, so we would like to ask for a working group adoption.
ask for questions. See if there's any questions.
Are there any questions to Bo?
So we will poll, so please scan, get ready for it. The question will be up in just a moment. So we're going to use the show of hands tool just to get an impression from those who are here. Oops, well, there's a typo in there, but if you support adoption of this draft, and again, adoption is always the starting point, not the end point. If you support, please raise hands. If you don't, please you do not raise hand. And so if you want to object, click the do not raise hands. So we have about a third of the room participating. Of those, there's most are supportive of adopting. We have a few people who object. Are any of those willing to come to the mic and give the reasons for objection? Well, keep in mind as we do adoption polls, if there's objections, we want to hear your technical reason for that objection. So you don't have to do it now, but we will expect any objections to be raised on the list and substantiated. I think we have a minute or two to discuss them. So face-to-face or virtual, it's a good opportunity. Okay, seems like we should move on. Okay.
Thank you.
Hi, this is Iwa from FutureWay, and I'm presenting the IETF network slice topology Young model on behalf of the co-authors and contributors. Next page. Right, so again, the motivation of this draft is that as specified in the network slice framework, sometimes a customer might wanted to have an additional level of control over the to customize the service path for network connections in the network slice. And also in some of the use cases, if I sit from a customer's perspective, I may want to ask for some sort of resource sharing instead of putting dedicated resource for each of the network connections. Basically, in that I could save my cost, right? And in that sense, the resources are reserved at the first step, but they are not activated. And then based on my needs, I could activate any connection using the resources that I have reserved at any moment. And the way we talk about the resource sharing could be between the connections or connectivity constructs that could belong to the same or different network slices, but always from the same customer. And we are not talking about sharing between different customers. So the current network slice MBI model that was presented in the last session dealt with connectivity-based network slicing, which means we would need to have built a dedicated connection with resources allocated for each of the connections. And then, so in the case that, let's say we wanted to have resource sharing between different connections, one way we could do is to create on-demand reconfiguration of the of the connections within the network slice. But then that means there will be no guarantee that the resources are always available when you build a new connection within the same network slice. Right? So in that way, what we are going towards is we could actually make use of a topology
which we call customized topology, to help with those demands. What the customized topology could do is to create a way to express customized control, right? And for example, the explicit path over that topology is the usual suspect, and then we could have the topology to express other related constraints like diversities or even protection and restoration over a particular topology if we need to. And then what the customized topology actually encode is a resource reservation request that was sent from the customer to the provider, saying that, oh, here is the topology that I need you to realize, and this is this, and please reserve all the resources so I could play around with my connection at any moment within the topology. And also wanted to point out that the way how the customer would use a customized topology for network slices is totally complementary, meaning that if you're only interested in connections, you just go with the using the base model. But if you wanted to have some additional level of control, you could go beyond that and create a customized topology for that purpose. Next page. So before we dive a little bit further, there are always some confusion around the terminologies because the customized topology we're talking about might reflect different thoughts, right? So here, within the context of this draft, what we are defining is a customized topology is a topology that is specified by the customer as an input to the network slice provider. And whereas in another terminology, we used to hear about a way called abstract topology. And here we want to make a clear distinction that an abstract topology is a kind of topology that is exposed by a network slice customer to the provider, by a network slice provider to the customer before the creation of network slices. And then we also hear about other kind of topology like the NRP topology, which is internal to the NSC to create to realize the network slices. So here we're only talking about a customized topology, and the description about abstract topology or NRP topology is not in the scope of this document.
Aiho, do you want to take questions now or
yeah,
later?
Go ahead. Yeah.
Hi, Swami from Nokia. I cannot kind of understand the difference in between the abstract and the customized topology, because I would kind of imagine that the topology is provided by the network itself or the service provider, right? And in a sense that you would have the customer select a topology from something that's available in the abstract, and not the other way around.
Right. So that's the main difference, I would say. Like what you describe is a type of abstract topology that the provider would build and expose to the customer, right? Where we're saying here is we got the customer could construct a topology and throw that topology to the provider to realize. It's in a different direction, right? But I'll give you examples in the next few slides if you.
Okay. Now, kind of, it's a little bit difficult to kind of
understand
what that represents, right?
Right. So
right? So that the not able to understand the semantics here, but okay. Anyway.
Okay.
Just a point.
Yeah.
Pawan Biram, I think I agree with Swami. 8795, RC 8795 does define customized topology. It's there's also native topology in there.
Yeah.
If you read through the customized topology definition in 8.7 and 5, it seems to be a combination of the two that you have here. I think you can move on from the slide. It's not adding much to the discussion, but I would encourage you to revisit 8.7 and 5 definition and then correct this.
On the customized, yeah.
Yeah.
Because this model also augments 8345.
Yeah, but from a
right?
terminology point of view, I think there is some discrepancy here, but yeah, you
Okay.
can move on to the next.
Okay, okay, fair enough.
Just one minor comment here. Maybe more than customized topology is intended topology, right? I think is the intention.
Yeah, that could be.
Is the intention of the someone who requested to have, and you will get something or not. Thank you.
Okay, points well taken. I'll take a look at the definitions. Okay, so next page. So some history with this draft is in previous versions of this draft, we positioned it as sort of like an alternative model for network slicing MBI, which can both expose a topology used by the provider as well as the definition of a customized topology with built into the same model. So with a later version of this draft, we start to reposition it to basically to support only customized topologies or intended topologies, if you call. Yeah, next page. So here I want to give a brief example of how this customized topology could be used to serve for the customer needs. So here we have a customer of a TV broadcasting customer with a bunch of stadiums and a TV station on the other end connecting to a service provider's network. So as a customer, I would like to request a network slice, which allows the stadiums on the left to share the same bandwidth broadcasting events to the TV station. And what I'm asking for is the use of the bandwidth could be alternated between the different stadiums depending on the events that are broadcasted or hosted on a particular stadium. But I'm asking is the bandwidth must be available at the time of request. And also I don't have a predefined schedule, of when the TV broadcast would happen, right? So we have a couple of options here. If we use a network connection-based network slices, we could create a network slice with dedicated connection between each stadium to the TV station. What does it mean to the customer is they're going to pay for 3 times of needed bandwidth. As another option, where I could create a network slice that, let's say, start with 1 connection between the stadium and TV station, and then I reconfigure that depending on my schedule. But the problem with that is the bandwidth at the time of requesting the connection might not be available from the provider. So I don't have a guaranteed kind of use of the bandwidth at the moment when I need it, right? So next page. So alternatively, what we could do is we could actually create a customized topology as shown in the picture, where I have a node, a virtual node, or a node that represents the 3 stadiums on the left. And then I have another node that represents the TV station on the right. And with the link between the 2 nodes, basically what I'm trying to say is I wanted to have a shared link between the 3 stadiums and the TV station. And I intend to only allocate this much bandwidth. And I have the full control of when I will be using the bandwidth and for which stadium, right? That I can do that dynamically as soon as I have the knowledge that this topology is sent to the provider and the bandwidth is reserved. So of course, in this process, we need to have the provider's controller, the network slice controller, to work with the underlying network to realize the resource reservation. But the intent from the customer is expressed to the provider as a customized topology in this case. Yeah. Daniele? Oh, okay. Yeah, go ahead.
If
Next page.
You may want to start summarizing and then take questions.
Right. I think I have maybe only. Oh, I have a lot more. Okay. So basically, the point is we see there are places where we could use the customized topology to allow a customer to have a richer control of what they want to reserve and use in terms of the resources for a network slice. And this is complementary to the mechanism that is already built with the network slice MBI. So we wanted to bring this to the working group and seek interest in adopting this work. Yeah.
Yeah, we
right.
can go to the. You want to go to the open issue? And
Yeah.
the
So.
discussion?
Right. So one of the open issues, as also discussed yesterday, is the current network slice MBI Yang has a reference to a customized topology, basically a leaf ref without any specification of how to use it. As I also said yesterday, maybe a good idea is to move this reference to this draft. So we have a clear cut between the connectivity-based network slices versus resource reservation-based network slices with topology. So that's the main point.
Just summarizing the discussion from yesterday, I think the proposal from Luis that you have in the first draft of have a empty container and just as a placeholder, and then here augment everything on that.
Yeah, that's possible, but the point is the leaf ref to the network topology would be best moved to.
Yeah, but that will be inside this container, so that there is not a leaf ref; it's just a placeholder.
Right. We could put a placeholder in there, but that any definition about the reference to topology should be moved. Yeah.
Daniele Ceccarelli. So when I read the draft for the first time, I said, okay, the requirement is clear. Mm-hmm. It's something that we need. Mm-hmm. We just needed to add 2-3 parameters to the ICTM virtual network, and then that's done. But then that's not the path that you follow. What I don't understand is why. I mean, to me, it was the immediate solution. It was already there. The purpose is the same. And the more examples you add, the more I think the virtual network was perfectly fitting here. I don't understand why it wasn't used. Maybe...
Are you referring to the virtual, the ICT-MVN solution?
Yes.
Yes. Yeah, I mean.
I mean, to me, it was the most obvious solution to use to augment instead of something new.
Well, if we consider VN as in a scope for network slices, I would be okay to use the VN for that. But I think the consensus from the working group is to not reference any part of the VN solution and go straight with network slice definition.
Yeah, but if I correctly remember, we kept the VN detached from ACTN. Do you remember we had the discussion years ago, mm-hmm. Whether it was totally linked to ACTN or something that was decoupled. In the end, we made it decoupled, so why not using it? Probably Italy wants to answer.
Yes, I think the question is much broader than this. And my understanding when I compare network slicing and VN is basically is a different type of language. VN is more focused on express intent in terms of T matrix, while I see network slicing is more expressing intent in terms of SLO, SLE.
That's why you said it just has 2-3 parameters.
Yeah, but VN, yeah, that's more or less what we are doing.
Yeah.
Sorry?
I think we should go to Bo.
Yeah, Bo is next one in the queue.
I'd like to add something here because actually in the network slice service model that you can like put the 3 connection into a connection group and add a SLO constraint there. I think Tariq, before he proposed that constraint also that several connections have a 1 constraint. So that's something you can consider. Yeah.
Okay.
Morning, Reza Rukoy from Siena. Just for the clarity of discussion that we had yesterday for NBI draw as a quarter or both. So the summary is we keep whatever we have on the NBI Yang model as it is today. So there is a reference, a general reference to any technology or to any topology in the Yang model. In addition to that, if somebody wants to realize or request, not realize, request a NBI from the NBI perspective, a network slice with a specific topology and path in mind, they can go with the second approach that they can take this model, and in that model, they can augment the NBI Yang with anything that they have. So basically, the solution that we have is both satisfying both, and there is no dependency between draft because our draft is almost at the end for the last call, but this draft is at the beginning. So with that, we are satisfying the request for the specific topology if it's needed, generic topology, and everything should work. So this is just a completeness of discussion I had yesterday. I postponed that one to today's discussion. Just want to make sure everybody is clear. Thank you.
Does that mean to keep the current reference to within the NSMBI?
Okay. Yeah, I think we can take it to the list.
Okay.
I think we keep coming back to the point that Daniele made earlier about using existing work. But yeah, we need to close that issue on the list and then move forward.
We can bring it to the list.
G.
Morning, everyone. Sorry. Jidon from Huawei, and I'm going to give an update about the draft on the realization of composite IETF network slices. Okay, next page, please. Okay, here's some background. We know that IETF network slice in framework has described the concept of a network slice service and also how it can be realized by mapping the network slice connectivity constructs to the NRPs. And in some scenarios, IETF network slice may span multiple domains and may also be further sliced to provide some fine granular connectivity and the resources to the hierarchical customers and services. So this part is not fully covered in the current IETF network slice framework document. Well, it seems useful to elaborate on this part, including the slice scenarios and the realization considerations for this multi-domain and the hierarchical network slice uses. So according to the working group chair's suggestion, we have combined the two separate drafts. Previously was on the end-to-end network slice and the hierarchical network slice respectively. We merge these two documents into one document on the composite network slices. Okay, so here we are presenting this update after the merge. Okay, next page. First, we introduce some of the use cases for the multi-domain network slices and the hierarchical network slices. For the multi-domain case, we take this 5G end-to-end network slice as an example. So in this case, the multiple 5G end-to-end network slices can be carried in one or multiple multi-domain IETF network slice. And the multi-domain IETF network slices can be mapped to the multi-domain NRPs. And consequently, the multi-domain NRP can be achieved as a concatenation of a group of the intra-domain NRPs as shown in this picture. So this is the multi-domain cases for the composite network slices. Okay, next page. We also introduced some of the typical use cases of hierarchical network slices. As shown in this picture, we can have first level network slices built on the physical underlay network. Then we can have further slices, the level 2 slices in each first level network slices. The typical cases are listed in this page. We can have maybe, for example, level 1 slice for a specific industrial service. Then we can have separate customer network slices in this industry network slice. And another case is we can have a first slice for a specific customer, where we have the second level network slices for each specific application of this service customer. Then the third case is for some wholesale network slice cases, we can have a wholesale network slice provided for a specific, maybe tier 2 or the operator. Then this it can use this wholesale network slice to further provide level 2 network slices for his customers. Okay, next page. Here, from this page, we will introduce some of the realization considerations for the composite network slices. The first part is about the resource partitioning in the composite network slice scenarios. We will have a multi-domain network slice. We will need to build, firstly, we will need to establish the intra-domain NRPs within each local domain of the network. And we can use an appropriate set of network resources allocated for each intra-domain NRPs. Then this intra-domain NRPs can be used to constitute the multi-domain NRPs, which are used to carry this end-to-end network slice service. And in the case of the hierarchical network slices, the network resources to build NRPs hierarchically, the network resources may also need to be partitioned hierarchically in the network. And for both these cases, different technologies may be used for the resource partitioning in the different network domains or in different network slice hierarchy. So this is, we can have flexible combination of different technologies for the resource partitioning case. Okay, next page.
Do you want to take question now or?
Okay, maybe now. Thank you.
Tarek?
Tarek with Cisco. We have a working group adopted document IP MPLS NRP. It talks about interdomain NRPs as well as intra-domain NRP. So is there content you think can augment that document? Seems that there is intersection.
Yeah, I haven't checked the details in that part. Maybe we can discuss about this coordination in both documents offline. Thank you. Okay, next page, please. Thank you. So the second consideration is about the identifiers. Depends on the realization mechanisms. We may need to introduce several composite slice related identifiers, either in the management plane, the control plane, or the data plane. Such as we need an identifier for the intra-domain NRP. This will be the same as the domain-wide NRP ID as described in the NRP scalability draft. And in addition, we will need some multi-domain NRP ID to facilitate the concatenation of the multiple intra-domain NRPs into a multi-domain NRP. And for the 5G network slice, end-to-end slice service case, the identifier of the 5G network slice, called NSSAI, may also be used by the transport network for the service mapping and the monitoring at the 5G network slice granularity. And for the hierarchical network slice case, we may also need the identifier to be hierarchically encapsulated or used to identify the different levels of NRPs in the different network planes. Okay, next page. We also consider the data plane encapsulations for the hierarchical and end-to-end network slices. For example, we may use a multi-domain NRP ID in the packet for the mapping of the multi-domain NRPs to the each intra-domain NRP at the border of the each local NRP domains. And the identifier for the hierarchical NRP may be defined in different manners. Depends on whether we reuse existing fields for the NRP identification, or we introduce a dedicated NRP ID in each level. And for the 5G network slice cases, as I just mentioned, the 5G slice identifier may also be used in the transport network for the service mapping and the management. Okay, next page. The control plane of the multi-domain network slices In general, this one will be similar to the control mechanisms for the interdomain VPN services, possibly with some additional network slice characteristics being signaled in the control protocols. And in this case, the control interdomain option C is preferred because it can simplify the network slice service endpoint provisioning, while the option A and option B are not preclude, just we are focusing on the option C mode. And we also need to, for the control plane, it may also need to be used to establish the NRPs within each domain and for the concatenation of the intradomain NRPs into the multi-domain NRPs. Well, the assignment of the multi-domain NRP ID may be done by a multi-domain network slice controller. This is something we need a global coordination. And for the hierarchical network slice cases, the control plane will need to be used to advertise or distribute the NRP information in each level to among the network nodes and also to the controller. Well, this specific protocol mechanism will depend on how we will model the network resource partition in each level. Okay, next page. I think I went through these considerations quickly in this presentation, but the details are in the draft. So we appreciate people can review this draft and give the further feedbacks. I also think this document is a useful complementation draft to the existing network slice framework document, because we have seen these use cases for the multi-domain network slices and also the hierarchical network slices. So we need some guidance to be provided in the TEAS working group. So I also would like to request for the working group adoption on this document. Thank you.
Thanks. Any questions for G? So you did go through the process of merging two documents already. It's still an informational document.
Right.
I think we're going to ask you to consider merging it with other document. Look at options for merging with NSIPMPLS document. Consider the feasibility of that, and then we can discuss that further on the list. Because that, like I said earlier, yesterday, we are looking at those two existing NRP documents to cover all aspects of NRP. So if this is just a variant, and like Tarek mentioned, there is a placeholder that talks about interdomain NRP instantiation in the document already. Explore options to merge, and then we can discuss that further on the list.
Okay, we can consider this after the review. Okay, thank you.
Thank you.
I think it was presented in remote, Samir.
Hello?
Yeah, please go ahead. Yeah, hi, we can hear you,
Okay.
Samir.
Perfect. So I'm presenting on behalf the other authors of the attachment circuit drafts. Next, please. So just a brief reminder and scope of the work that we have been doing. So we have 4 different drafts. The first one defines the attachment circuit common, which specify a set of library and reusable types, identities, and grouping. This is used across the different attachment circuits model. Then we specify the attachment circuit service model. This specific document does not make any assumption about the internal structure or the nature of the service. It includes all the reusable groupings that we have defined in the common, and expose the attachment circuit and be the reference that can be used for the service path placement requests. We have a third model or a third draft, that is the attachment circuit network model. This is a network model that keeps the reference between the attachment circuit and the service access points. This presents a complete network view of the attachment circuit. And finally, we have the attachment circuit glue, which is like a middle model that allows us to connect the different LX and SM definitions or the existing ones with the attachment circuits. So you will notice that some information that we have in attachment circuits can be reused in the different network and service model. So this glue definition allows us to specify and connect the information between the different models. Next, please. So for this work, we have regular meetings. As you may see in the GitHub webpage, we have advanced a lot of issues during the last 3 months. So we have a project view as the one that you're seeing in the slides, where we have different issues open by the authors and also the contributors, and we have advanced some of them. The major advances in the last IETF meetings are covered by the inclusion of the bidder location. We have also simplified some of the profiles definition, the MTU and bandwidth definition, and we explain how to provision specific identifiers. For example, the VLAN ID. In the bi-weekly meetings, we review all the issues, and also, well, we commit and progress new advances done in both in the YANG definitions and in the ID documents. Next, please. So this is one of the major advances that we have since the previous IETF meeting, and is we have received a request from the ORAN to include a reference between the IETF network APIs and the ORAN mobile network orchestration model. So this specific request allow us to define how to use the IETF-based APIs as an interface between the transport network orchestration and the mobile network orchestration. We also use this specific reference to use the network slice services and the attachment circuits as part of the data models of the transport network slice management. So next, please. The change request has been accepted by the 3GPP. You have the link available there to see the specific definition, but the main advance is the definition of new data type, which is the connection point information. So this data type contains information required to identify a connection point outside the scope of the 3GPP MIP definition or MIP domain, and link it with the attachment circuit data model. So this touch point contains enough information to resolve the associated connection between the transport domain controller and the mobile network orchestration. Next, please. We have also advances regarding these two specific drafts that has been advanced in this working group. So the first one is the 5G network slice application. So this draft discusses how to map the 3GPP NRM objects to the IETF attachment circuit. So we have been working to identify the gaps and reported it back. And the second draft is the network slice MBA YANG data model. These drafts now include a specific parameter, which is the attachment circuit service name, that indicates the name of the service, and it can be used for specific association purposes or to refer to the attachment circuit that has been created. The specification that we have done also include a discussion about how the attachment circuit service model and the attachment circuit common definition can be used for future extensions. Next, please. So the next steps and the and what we expect about this work is the scope and content is very more stable. All the work that we have been done in this for specific documents has been built on top of the some OPSA working group RFCs that we already did. So the L3NM, L2NM, the service access point, and the VPN common. So all the work and all the feedback that we have collected from those specific RFCs has been included as part of this attachment circuit definition. The attachment circuit is a work that is not only scoping the framework of the IETF, but it has been also extended to other standardization organizations. And during this IETF 117, we have seek for the adoption of these attachment circuit documents in the OPSA working group. So this was presented last Wednesday in the OPSA working group meeting, and we have requested the adoption there. So for that, for now, that's all.
Okay, so are there questions for Samir?
So on the liaison you mentioned, there was no action requested as part of the formal liaison process. In the text, it does talk about looking for comments. Please review. If you think we need to respond formally, suggest something on the list. But again, the organization didn't ask for any action by the IETF, any formal action. Thank you.
So I think the next one
Luis.
is Luis.
Thank you.
Oh, no, he's still here.
Hello again, Luis from Telefonica. I will present on behalf of my co-authors this draft about DC-aware, the data center aware T topology model. Next, please. So the problem statement or the topic that we want to address here is essentially the fact of what the common way now of deploying services is doing that the operators deploy more and more data center capabilities or computing capabilities around the network. So we are attaching these facilities and we are interconnecting them through the transport network, through the network basically. So we consider interesting to have a joint topological view of both networking and computing resources available, so in such a way that we can define the proper traffic engineering decisions according to the data that we could collect from in a combined manner, right? So this is somehow similar to the approach that is being followed in the draft about service function aware topology, but not looking at the service functions, but looking at the compute resources, so the availability of those resources as attached in the network, as you can see in the graph, in the picture. So the data center POPs, or the compute facility POPs, could be described either in terms of resource capabilities, so CPU available or allocatable, or memory, storage, and so, or alternatively, they could be described in terms of bundles, typically named quotas or flavors by different cloud providers. So there is a kind of example here in this table where basically the different flavors define the amount of CPUs, memory, RAM, storage, and so on so far. Next, please. So the changes that we have done from a previous version, we have added the compute node to the model before. Well, you will see in the subsequent slide, but basically the concept of compute node was there. And the compute node, just to comment, is the asset that is being actually virtualized, and then let's say the asset that has the proper compute capability. So we added this into the model for completeness. Apart from that, we have improved the description of related to the data center information. We added text referring to different cloud managers like Kubernetes, OpenStack, and so different solutions as the mean of collecting compute node information. Again, the allocatable CPUs, the available memory, and this kind of stuff. Also, we elaborated a little bit more the text referring to the way of handling the bundles or quotas. So mentioning and describing what is being done by different cloud providers like Microsoft Azure, Amazon Web Services, or Google Cloud Platform. So in general, they are working with this idea of quota. Next, please. This is simply for visualizing the changes in the model. We, as said, we added the notion of compute node. All what was before about related the hypervisor, this virtualization mechanism would be now depending on the compute node entry, and then also let's say refining the definition of compute node with the identifier, IP address, and so on so far. Next, please. So as a summary, we have presented the document in 2 IETFs already. As next steps, we would like to assess the validity of the YAM model, if it is complete or not complete, what we are missing, what could be necessary to have there. And yeah, the objective would be to prepare a new version with the feedback that we could collect from the working group, also with a refinement of the model. So probably we are missing things. So the idea would be to complete all of that and yeah, get feedback from you and prepare a new version. So as said, any feedback or comment is more than welcome. Thank you.
Daniele?
Daniele Ceccarelli. So I wanted to understand how you foresee this model to be used, in the sense that so the data center information is most likely something that is collected by, pass me the term, a cloud controller, right?
Yeah.
And then which is operated by a department.
Yeah.
Then you have the transport network, which is discovered by the transport controller. And then there is something on top that merges the information and exposes this merged topology. How does it work?
That would be what we have in mind. So essentially, the data center, we expect to have a data center gateway. So that would be the one linking, let's say, what is the compute capabilities with the transport capabilities. So we can follow let's say the attachment of the compute capabilities via the data center gateway to the rest of the network. And yeah, and the way or the purpose of having this information would be for the step of instantiating services, and so that we could, before taking the decision on where to instantiate the service, to have a clear view what would be the connectivity that we could have between those data centers, in terms of traffic engineering.
So if I get it right, that the merge of the information is not done by this super controller, but is the data center gateway?
No, it would be that on top controllers, yes.
Okay.
Yeah.
And is it something that you already have in mind? Because I never heard about this super controller putting together data center and transport worlds.
There could be someone needs to take the decision of where to deploy and having all the information. Could be that kind of piece that could. I mean, it's something that we need to figure out who could play that role, and maybe if there is missing that piece, or it could be played by the transport or the cloud or so. But it's a matter of defining. We are not entering in that space yet. We are just working in, let's say, in the low level. Later on, we will see.
And how does this fit with the work that is done in CATS?
Well, in CATS, the kind of information, the compute information that you could require is linked to the service function. So it's the one being consumed. Here we will be one step before, which is at the time of instantiating. So we need to understand the capabilities for instantiating the functions. Later on,
Understood.
Thank you.
Thanks.
So while Jeff is asking his questions, we're going to do a poll of interest of the group, where we're going to ask if you are interested and you've read the draft, raise your hand. If you're interested and have not, lower your hand. Do not raise your hand. If you don't care about it, don't participate.
Jeff Tensura, NVIDIA. A couple of questions here. How dynamic is the data you're going to distribute? Is it current load of the data center or hardware deployed?
So you mean how dynamic is there?
Yeah, because the load is dynamic. It
Yeah. And the availability of resources and so. Yeah, this is why probably seems to be more scalable to go in the direction of flavors, because it could be something much more static in the sense that you can only refer the availability of flavors and not the raw resources. This is something that we need to investigate. how precisely how dynamic could be that information, and what would be the moment of consuming that information. If it's at the time of just instantiating, you will have a kind of static picture of that precise moment, or if it's something that you need to continuously monitoring, probably going through the raw resources could be something will present probably some scalability issues. Yeah. Yeah.
So, kind of piece of advice, it's very difficult to normalize the metrics, right? Because you've got at least a compute, storage, a whole set of resources that don't necessarily interact with each other.
Yeah.
What you could do is use electrical capacity of a data center in kilowatts to signal. At the end, amount of electricity you could draw, the size of the data center, ability to cool down particular elements in data center. So that could be the normalized metric you're looking for.
Okay.
And practical consideration, the system are not connected. Those people, they don't know each other, they don't necessarily like each other even.
Yeah. Thank you, Jeff.
So Greg is not in queue, but he'll go ahead. And if anyone wants to enter, if anyone wants to enter the queue who is not participating because they don't like this draft, we'd love to hear from you, but briefly.
Okay, Greg Mirsky Erickson. Actually, I tried to get in the queue, but because of that, I cannot do it.
There's a dismiss button at the bottom. It's a little annoying.
Okay, but yeah. I wanted my. Okay, so I think that I concur with Jeff because what I understood that you envision that information will be propagated from data center gateway, and that seems to be unclear to me. So it's unclear to me how it can obtain any information. So if this information is provisioned, then why it has to hop through the data center gateway? It's probably better to be shared through the management plane, from orchestrator to orchestrator. And even more so, we can imagine that a data center has its own orchestration entity, so that plugging it and sharing in hierarchical model, as for example in a slicing, right, when we have different slices have its own orchestrator that go to their end-to-end orchestrator. So the data center entity of sorts will have information and feed in this information. It's just a thought.
No, well, thanks, Greg. That's a good comment. Only to comment, the data center gateway for sure will be the link, the point linking both worlds, not necessarily the one propagating. Could be, as you said, via the cloud management. Also, we could have propagation from the data center, thinking on BGP or things like that. But for sure, will be the link, let's say, the topological link between both worlds, but not necessarily the one disseminating the information.
Right, and I would be interested in discussion of this and looking forward for your updates. But what I would encourage is that information will flow only one way, so that basically there will be no possibility of confusion when information of the same matter comes from different sources.
Thank you. Thank you.
All right. Thank you, Luis. I'd say you had a little bit of tepid interest. It wasn't a huge amount of participation in the response. Personally, as a contributor, I'm interested in hearing more. So I look forward to, like Greg said, reading your update and tracking the work. Thank you.
So, Nigel, did you solve your connectivity issues?
I hope so. Can you hear me?
Yeah, perfect.
Excellent. Okay. You could either hear me or see me. I couldn't get a device that would do both. So you're hearing that. But it was better than trying to lip read. Great. Okay. Excellent. Thank you. So Nigel Davis, Sienna, I'm going to present this material that we presented at Ops earlier in the week. So I'm going to make a couple of comments before we scroll on the slides. There are three of us on as authors there. I started the working towards this work independent of the digital map, digital twin work, as we'd been trying to use RFC 8345 for various network cases and had some challenges. And then I encountered the digital map requirements for the same things we've combined on this. And the work's not, just to be clear as well, it's not been adopted by Ops. We didn't ask for that. We want to do a bit more work ourselves to refine the material before we proceed with that sort of request. So it's not been adopted, so just so you know that. If you could go on to the next slide, then I'll then work through the material. Thank you. So just to go through the summary, the work is to improve the capabilities to support multi-point structures, both unidirectional and bidirectional. It's not, we're not removing any current capabilities. That's not the intention to completely replace something with something else at all. The current RC8345 focuses on point-to-point unidirectional, and the intention is to keep exactly that support in RC8345. It suggests use of a pseudo node to deal with multi-point. This is the area we think we're aiming to improve on, and I'll explain how. In general, there are many multi-point unidirectional, bidirectional cases in the environment, and we've had a lot of experience in other activities where there are models that do support multi-point in a more of a sort of a holistic way. So I wanted to work through what this proposal is on that. And the draft itself, I'm only going to look at one of the proposals in the draft, but there are two alternatives in the draft. They're both intended to be backward compatible, although we need to validate that fully. One is Yang and instance representation backward compatible. The other one modifies the Yang, but it should result in the same instance representations in JSON or whatever. So the Yang isn't directly compatible, but the instantiation should be. And the intention of this is it covers both multi-point unidirectional and bidirectional, and also point-to-point unidirectional and bidirectional. So I'll talk to that. Perhaps you can go on to the next slide, please. So as I said, there are many cases of services with network connectivities representations that require a bidirectional, even asymmetric representation. The mechanism we have here is able to support symmetric and asymmetric forms. And a lot of the transport technologies result in or have bidirectional protocols that force a return path, even if it isn't the same size and so on. There's some handshaking or whatever else. There's maybe symmetric use of a bidirectional solution. And when we look at device management and control models from other bodies, and I can go right back to TL1, which used a multi-point uni-bi representation. TMF, MTN used a multi-point uni-bi representation. ONF TAPI does, and a lot of proprietary management solutions do internally. So this is not a new concept. It's more trying to get this to be an opportunity to expose these structures in maybe a more uniform and more simple way. And the multi-point uni-bi, I use uni-bi here, by the way, to sort of summarize unidirectional and bidirectional. It emphasizes the atomic unit of the thing you're trying to achieve. So you could imagine this coming in from a service end. You state a service, you want a multi-pointed bidirectional construct, and you know that's what you're looking for, and you don't want to get a load of bits back. Essentially, you want to get that construct back. So that was the orientation of this, really, essentially. If you go on to the next slide, please. Thank you. So I'm not going to dig into this. There are some issues with the Yang here. It's a first sketch of the initial draft. So there are things we've been talking on this week, actually, that we want to improve. But what we've done here, this particular simple addition takes advantage of the fact that RC8345 links essentially have optional points in them. So the source and destination points are optional, essentially. So you can have no source and no destination in a link. And of course, it doesn't tend to be much of a link, but the Yang lets you have nothing in it. And on that basis, we can add a point list, an optional point list to the structure. that can also have no points in it, and therefore you can, with this particular form, you can either use the source and destination as it was used previously, or you could use the point list. There's no control over how this is used. The other enhancement in the draft takes the source and destination points out and then augments them back in again, and we believe that produces the same instance output essentially. And then the augment can be controlled with if feature and so on, such that you can turn the traditional form on or the new form on, and off, and you can sort of make them alternatives and so on. So it's slightly more sophisticated. So the yang doesn't look the same, but the results should be the same. This one's simple, obviously. And we've been just on this particular sort of things, we've been looking at the point ID, and we believe we can not use point ID and just simply use the TP and node identifiers to make the instance unique. We've looked at roles and so on. We're looking for improvements in that, and we've got directionality on both the points and on the link itself. And I won't explain the detail now. So
Nigel, can you come closer to the mic a little bit? We hear.
Oh, sorry. Is that any better or? Yeah, I can't get much closer because I'm nearly eating the microphone at the moment, actually. So be careful. So if you go to the next slide, I'll then be able to wrap up then. So the structure is the links represented as a brown single entity here, multiple points on it. Each one references a TP. This one happens to be a root and leaf configuration. So the specification entity below represents the flows, and you can see there's no flow between the two right-hand points, but there's flows between all other points. If I wanted to represent with the current solution, I need to have what's shown on the right, which is a collection of point-to-point unidirectional links to a pseudonode, and that pseudonode then needs to have a set of rules that convey the specification-like thing that's shown below in the left-hand picture. So what we've essentially done is pulled the boundary of the pseudonodes out so it touches the TPs, and then said that's the link. So it's essentially that. The structure should be usable for point-to-point bidirectional, point-to-multipoint bidirectional, unidirectional, and also, of course, point-to-point unidirectional. But as I said, the modification isn't intended to replace the current structure. It's intended to give an additional opportunity. So if you could move on to the next slide. So there are other things in 8245 we don't tackle in this draft that we want to tackle. I'm not going to go through these in detail, but we're obviously going to work on these. The termination direction itself, the termination can be unidirectional. Specification of capability using more of a rules-based solution to identify what flows are legal. Links between networks, so from one network to another outside. Improving navigation potentially, we need to discuss that in detail as to whether it's actually relevant for an interface. Relationship between roles, generalized models of flow, and sublayering, layering, and general in 8345, which is a little bit ambiguous. So if you move on to the next slide, that's my last slide. What we're doing is seeking in obviously everywhere, seeking support for the draft and looking at how to progress best. We've got some more work we know we need to do in the other areas. I want to cover those two. So that's the summary.
Okay, thank you very much, Nigel. So I would expect the folks here that you are using the topology as one of our basic foundations. So these are
absolutely
profound changes. So here I would expect feedback from here whether this is useful things to do. They are, at least I should encourage people to read them, to consider them. You may like it or not. I mean, but at least I think it's interesting to consider. So if there are any questions now to Nigel, you have the opportunity. Otherwise, I mean, we'll have the list to
absolutely. And just to re-emphasize one point, we're not taking away the current capability. We're simply adding an additional capability to hopefully improve the representation for some of the more complicated structures.
Well, thank you very much. This was definitely interesting.
Yeah.
We've reached the end of our session. Very much appreciate everyone participating locally, remotely. You know, it's a long week, and we appreciate you staying almost to the bitter end. And looking forward to seeing you at 118 in Prague.
Thank you.
All right. It's a long week. I think it's very interesting.
People might not like the concept. I know it's controversial.
I don't know about that. Stiff from weeping.
That's why I've been like hovering at the parameters runs, especially toward the end of every Monday. I just can't set it.
I used to